In continuation to the previous video, we are going to continue with the revision problems in this video. Uh, so let's look into this question. You are seeing some oblique projection from the top of a tower of height h. From certain tower of unknown height h, it was found that the maximum range at a projection speed 10 meter per second was obtained at an angle of 30 degrees above the horizon, as shown in the figure. You are asked to give the range of this projectile, and given g is 10, and what is the height of the tower. These are two questions we could see in this problem. Firstly, let's go to the working of uh, projection from the top of the tower. So let's use the equation of trajectory. As we know, even the equation for the trajectory in this case also the same as like projection from ground obliquely. So y equal to x tan theta minus gx square by 2u square cos square theta in denominator will become secant square theta. I think I can also put it as 1 plus tan square theta. The same equation in denominator we were having cos square theta, that goes numerator secant square theta, it becomes 1 plus tan square theta. For x equal to r, I mean that is x maximum horizontal range, y equal to minus h, because you can see as it reaches down, the displacement in the vertical direction is h and it's downward. So that is, you can put it here, minus h is equal to r tan theta minus gr square by 2u square 1 plus tan square theta. We, as r is the x maximum, as r equal to x max, we can write dr by d theta is 0. So let's differentiate. Anyway, minus h is fixed value. Differentiating with respect to theta, I'll get minus h is d by d of minus d by d theta of minus h is 0. And in the case of r tan theta, we'll have r secant square theta plus tan theta into dr by d theta. Anyway, this part is 0 because dr by d theta is 0. Minus g by 2u square I write outside. And I think I will have r square, d by d theta of r square is 0. D by d theta of r square plus r square tan square theta, that will become r square 2 tan theta, and the differentiation of tan theta gives me secant square theta, plus in the other part I will have tan square theta d by d theta of r square, that will be 0. So this part is 0, and of course this part is 0. Therefore finally I would be left with r secant square theta minus g by 2u square into 2r square tan theta secant square theta. So upon rearranging, I would get things like here 2 and 2 get cancelled. This secant square theta can be removed from the equation, and I would have okay, or else I'll write like this: r secant square theta should become equal to gr square by u square tan theta secant square theta. I can write. We can cancel the secant square theta. We can cancel an r. So I would be left with r is equal to u square by g tan theta. This is a range. The problem, you are given u, you are given theta. So you need to find that r. Therefore, r is equal to u square is 10 square by g will be 10 into tan 30. Tan 30 is 1 by root 3. So range is 10 root 3, and this is the maximum. You are asked to give the height of the tower. So as to find the height of the tower, we can substitute things into this part of the equation. We would get minus h is equal to 10 root 3 into tan 30 is 1 by root 3 minus 10 into 100 into 3. That will be 300 r square by 2 into 100 u square. And secant square theta, secant 30. Cos 30 is root 3 by 2, secant 30 is 2 by root 3. 2 by root 3 whole square, that will be 4 by 3. So if you solve this, minus h is 10 and 100 3 times, and that will be minus 20 on the right. So minus h is minus 10, so h is 10 meters. So the answer for the second part of the question is 10 meters, and the first part of the question is 10 root 3 meters. But sometimes maybe you would see the question asking theta in terms of h. So we got things like this. I'll just put up this too. I'm extending the discussion on this part. We got minus h is equal to r tan theta. We got minus h is equal to r tan theta, g r square by 2u square 1 plus tan square theta. And we got range as u square by g tan theta. Of course, we can put theta in terms of r, but generally r won't be given. Most of the times h would be given. In terms of h, if I want theta, then how? Then I will eliminate r. So that I'll get what? Minus h. If I eliminate r, in the place of r tan theta, I'll get u square by g minus g by 2u square. Instead of 1 plus tan square theta, I'll put secant square theta. R square is there. I'm writing here u power 4 by g square tan square theta. So minus h is u square by g minus u square, u power 4 gives me u square in numerator, 2 as it is in denominator, g in denominator will come, secant square theta, that's I think 1 by sine square theta will come, because I can write secant square theta as 1 by cos square theta. In denominator only I have tan square theta, that cos square theta and tan square theta is sine square theta. So let me rearrange. So I'll get u square by 2g 1 by sine square theta, u square by g plus h. So both sides I would cancel this, and I would have sine square theta equal to u square by 2 times u square plus gh. So do I get sine theta as u by under root 2 times u square plus gh. Therefore theta is sine inverse u by root 2 times u square plus gh And what is this theta? This theta corresponds to maximum R. Various angles you can project it, but for which angle the horizontal range for projection from the tower is maximum, and that would be this one. You might ask me, if I h is 0, what happens? You put h 0, you check theta will come 45. But when h is not 0, definitely theta is not 45. So this is an extended discussion with the problem. So you can just register this point. You can express theta in terms of sine inverse, or if you wish to do it in tan inverse, you can also do it. But this is the expression for the angle at which you have to project so that you get the maximum range. Switching to the next one. A small solid ball of density rho is held inside at point A cubical container of length L filled with an ideal liquid of density rho as shown in the figure. Now, if the container starts moving with constant acceleration A horizontally, and the ball is released from A simultaneously, then you got questions here. Hit the top of the container at end Q in all the four things. End Q is here, starting from here. Questions on what time it will hit and what acceleration. So you need to find acceleration and time, two things here, and answer this problem. So now here on the ball, as the container is accelerating, there is a pseudo force with respect to container MA, and of course gravitational force mg would be acting. For mg corresponding to mg, you will describe a buoyant force, and corresponding to ma, you will write a pseudo buoyant force. So corresponding to buoyant mg, you will have what? You'll have the buoyant force is density of the liquid into volume of the object into g. Here pseudo buoyant force is density of the liquid, volume of the object into this acceleration of the frame. So, but what is m? M is density of the ball into volume of the ball into acceleration. Here also density, volume into acceleration of gravity. So the resultant picture of these all forces, you can also show it like this. There is a net effect like this. 4 rho VA on the right side, rho VA on the left side will become 3 rho VA to the right and 3 rho VG upward. So resultant of all these would be directed like this. Net force on the ball would be, you can write 3 rho V outside root of A square plus G square. And you know this is the L by 2 position. Now the ball has to reach this position. When will it reach there? You need two things like time taken to reach there. For time taken to reach there in y direction, we get the equation. Displacement y is equal to half into acceleration in y direction into t square. I think this would be L by 2 into the acceleration in the y direction is force by mass. Force by mass is for AY, 3 rho Vg is a force by mass of the ball is rho V. So 3G. So 3G t square. So you can cancel 2 on both sides. You would have T is equal to root of L by 3g. This is the time taken to reach Q. And you need the acceleration of the frame. In x direction you can choose. In x direction the displacement is L. X is equal to half at square. Why are you using half at square? It's a in x direction uniform acceleration is there, and initial velocity ball is just released relative to the container the ball is initially at rest. So L is the displacement half into A I need to find. I got T square is L by 3g. T square is L by 3g. And the acceleration in x direction I bother. The acceleration in x direction is we have the force in x direction as a 3 rho VA. 3 rho VA is a force by rho V is the mass. So that's 3A. 3 times A. So let me put in the place of AX. L is equal to half 3A L by 3G. So you can cancel that 3. You can cancel 3 and 3 here. You can cancel L on both sides. And you can conclude the acceleration of the frame should be 2G. The acceleration of the frame should be 2G. So the acceleration of the frame required so that it can reach Q is 2G in the horizontal direction, and the time it will reach is root of L by 3G. If you see the options, you can just see you can see the option B for a ball to hit the top of the container, the NQ, the A is 2G, and ball, you can see C option, ball hits the top of the container at NQ after a time T equal to root L by 3G. So in addition to these solved problems, we are adding few questions in today's class. So you keep pause and copy down the questions and solve those questions, whose solutions discussion can be done in the next video. So I'm reading out those questions. This question yesterday, so we have seen. I'm going to the next one. This you have to try again. We can see this problem. A uniform rod of mass m and length L is kept on a horizontal surface. The rod receives an impulse J at its lowest position, normal to its length as shown. Then choose the correct statement. Options I'm reading. The velocity of point P just after impact is 2J by m. Velocity of point P just after impact is J by m. Kinetic energy after impact is J square by m. Kinetic energy after impact is 2J square by m. The other question is a cylinder of square base B into B is kept on a rough horizontal surface so that it cannot slide but topple only. It is filled with water up to a height h, and a small hole of area A is punched in it at a height h. Water leaks out horizontally from the hole C in the figure. The values of h for which the cylinder gets toppled is, you're given the options. You have to pick out the right option. Try these questions for this after watching the video, and then we will see the discussion of the posted questions of present video in the next video. Thank you.